Hello, my name is Ed Armstrong from Sharcnet, and today we're going to be presenting the second half of a two-part webinar on MySQL. Now, the previous webinar, we focused primarily on creating tables and accessing MySQL. On this one, we're going to focus on how to manipulate your tables by adding constraints and how to join multiple tables together. And this is really the meat of MySQL, in that it allows you, this is the starting point from which you can do so much more. And so the goal of today's webinar is not necessarily to show you the extent of everything that is possible with MySQL, as that couldn't be done in 2 one-hour webinars. It is to get you comfortable enough with the basic joins and constraints and table manipulations so that you can go on further and look up answers and be able to figure them out for yourself. So, first thing we're going to cover today is table constraints. And these are going to be used for our joins later on. Now, what I mean by a constraint is it's things like how to prevent certain data from entering your table, telling the data how it's supposed to be formatted, etc. So as a review from the previous seminar, we have this slide here, which is creating a table. The general convention being, we'll go back, general convention being the commands are in capitals, the variables are in lowercase, etc. So this is a table of employees. Each has an identifier, which is an integer, a first and last name, both variable chars, var chars, length 64, and a start, which is of type date. And you can create a table using that command. The first constraint we're going to show you is the unique constraint, and we're going to make ID integer unique, because you typically want your ID for employees or certain tables to be unique. You don't want to have copies. You don't want to have multiples of the same ID. And this will allow you to quickly search for a record. Instead of searching for them by first name or last name, which may not be unique, or start date, which also likely isn't unique, if you ensure that the ID is unique, you can now do searches on this table for single or multiple records. The unique is assumed for the constraint primary key, which is what you'll see much more often. And the primary key provides a unique identifier for each record in the table. Primary keys must be unique, and thus we don't have to specify that's unique, and they cannot contain null values. They must have a value of some sort. A table can only have one primary key, which can consist of multiple columns, but there can only be one key. But you can have multiple unique keys. And it's going to be a trade-off between space and performance in the end. If your column has, or you want to guarantee that your column doesn't have repeat values, you make it unique. If you want it to be the column from which you search from, you make it primary key, and of course unique is assumed. Another constraint is the not null constraint. As you can say things like, well, they have to have a first and a last name. We can make it not null. So if you insert a value into your table that's not included, or say you insert a row into your table and you omit a value that's not null, it's going to throw an error, and that you know that you've made a mistake. And this is just to make sure, this is mostly to make sure that your data is a little bit verified as you put it in, or other searches that you may perform, other SQL queries, which may rely on that value existing, will not fail because you've set up your table with a not null constraint. It can also have, as you can see here, multiple not nulls, unlike the primary key. The last constraint is the auto increments. We've put here on top of primary key, so you can have multiple constraints as seen by the ID row, column. So ID, integer, it's still a primary key, but now it's auto increment. And what that means is we no longer have to include a value into the table for that column. It will automatically increment it, because typically when you have a primary key or an ID of some sort, you're going to just want to start at 1 and go up to 2, 3, and so on and so forth. And that's what auto increment is going to do. It doesn't have to be on the primary key, which is why it's a separate keyword, but it often is. Now, table constraint. What I've shown you there would be column constraints. So instead of column constraints, you could add it as a table constraint. And this is just a slightly different syntax for your primary key. So as you'll see here, we've decided to make the primary key on email, and I've done that just to make a point that the primary key doesn't have to be an integer. It can be anything, and it can also be a combination of columns. It has to be unique, and that will be implied here. So it's a primary key, email at the end, as if you're putting in another row, or another column. Another way of another key, another constraint, is the foreign key constraint. And the foreign key is put in much like, it's a table constraint, so it's added as part of your create table command, and not put in up here with the row declarations. It's put down with the table declarations, if that follows. So we've gotten a foreign key. So what the foreign key does is it makes sure that this value, in this case role, which is a varchar, is going to reference another table, an outside table. So this is the first time that we're seeing two tables kind of coordinate. What's going to happen is every time that you insert a value into our table employees, it's going to make sure that the value role references role's name. So what that means is the roles table, which is a separate table, will have a column called name, which this will reference. It is not required, but it is strongly recommended that the column in the external table, or the foreign table, matches the column you declared in this table exactly. And that will allow your searches or your foreign key verifications to be much quicker. They should match. There's really no reason why they shouldn't. It's an efficiency issue, I suppose. Now, you can create these tables with these rows, but sometimes you will have created a table and you don't want to recreate again, or you want to change something. You enter the data, table's been around for a while, but you need to make some changes. In this case, you'll use the command alter table. Alter table name. And this is new for this seminar. We didn't introduce it last time, in that it changes the create table command that you did before without deleting the table. So there's the keyword is alter. You include the same table name. In this case, we are adding a constraint. So we'll add a constraint. When you alter the table and you add a constraint, you have to name the constraint. And you can reference that later on. Then the foreign key. So we're adding a foreign key columns. That would be the columns in the current table. Then references parent table, or external table columns, the other table. On delete action, on update action. And this is this command was copied from the MySQL manual. And on there, you'll see a lot of things that you don't need. For example, the on delete and on update are just things that you want to take place when you perform that action on your table. Typically, you'll just alter table, do what you want, and not necessarily include the whole command. But when you go and look up these commands, they're quite extensive in their options. So another way of altering a table, show create table name. Now I just kind of stuck that in here, hijacking the altering a table slide. And the reason I've done that is I'm going to show you in the second half of this seminar when we go to the command line. That will show you how the create table would look after all the alterations. And it gives you a bit more information than just describe table. Well, that's hijacking this slide, which is alter table drop foreign key constraint name. And the reason I've included this is to show you that you can also remove foreign keys from your table that you've previously added. And then, of course, the name that you gave it when you added the foreign key. Keep in mind, alter table can do a large number of things. This is just one aspect of alter table. You can also add rows, or like add new data to your table. You can also change your rows. You can remove them. You can change the order. You can do a number of things. You'd want to go look on your own. We could do a webinar alone on altering a table, but it's all quite straightforward. If you want to change something, use alter table. Now, those are just the basic commands that we covered, and then we're going to go into examples later on. But when talking about databases, you often abstract out and talk about data models. And the data models are what your database is trying to represent. And what we're going to do is we're just going to cover a couple of very basic data model relations. One-to-one, one-to-many, and many-to-many. And that is three ways in which you can talk about how tables or how data is related to each other. Now, the most trivial one is the one-to-one. For every country, there is one and only one capital. For every capital, there is one and only one country. And this is a one-to-one relationship. That means each piece of data is related to another piece of data in only one way. And this allows us, and this is how you would say the data in a table should be related on a one-to-one basis in order for them to be in the same table. If you were to split that into two different tables, you might be duplicating data you don't have to. And it's a very simple relationship. And of course, it exists when one row in a table is linked with exactly one row in another table. So sorry, when it's not linked. When you are, the next one is the one-to-many relationship. And this is the relationship between tables. We could put the relationship here. We could take Bob Jones and put it right beside class, and you'd have his name multiple times, but that's data duplication. And that's what we're trying to avoid. In the first case of data duplication is going to be the one-to-many relationship. So, for example, if you have a book will have many pages, but each page only belongs to one book. And that is a one-to-many. In this case, we have instructors. Each instructor has an ID, a unique ID. They have a name and an email. And these instructors have classes. Classes also have an ID, a code, an instructor ID. Now, instead of just putting the instructor name down there, or the instructor email, we've referenced it to the external table. And that's to say, for each and every instructor ID down here, there is a matching ID in the instructor column. Oh, sorry, in the instructor table. Now, as a point of convention, when you do a foreign key in a table, you have a foreign key constraint, you are going to include the external table name, in this case instructor, which should be instructor, not instructors, and underscore the row name. So instructor underscore ID references a row ID in table instructor. And the only reason we do this, it is not enforced by the language. It is so that it's a lot easier to write and remember what we're doing when we're doing SQL queries. The last relationship is a many-to-many relationship. And what this means is if you have a piece of data, it could be related to multiple pieces of data, and everything it's related to could be related backwards multiple ways. We can visualize it here in that a student can have many classes, and each class can have many students. The best way to represent this in a MySQL database or in a SQL database is by a third table. So instead of trying to figure out which way or where the data should be, the unique data is class. Class has its unique data. It's got a course code. It's got an instructor ID, which is an external table, and an ID of its own. And students have unique data, their name, their email, and their ID. In order to join them, we use a junction table. And the junction table will have the student ID and the class ID, and from which we can build other intermediate tables. We can use that data. If we want to export all of that information together, we can do a join. We will join the student table to the junction table. We'll join the class table to the junction table to build a new table which will represent the data we want. So it's not duplicated on the database, which makes it easier to manipulate, but it can be joined and combined. And that really is the guts of what we're getting to. So now I'm going to go through a list of the basic joins and how they're done, and then we'll go into examples of kind of what they're used for. So the overall join is a cross. So this is the most basic join, is a cross join. And a cross join is the Cartesian product of rows from tables in the join. In other words, it will produce a new row in a new table for every possible combination of rows. So this will be, if you look at it as a Venn diagram, is a union. It's a union of both. Now this join is mostly useless, but it's a starting point. It's just a showing from whence other joins come. So we'll just kind of focus on this one for a minute. If we have two countries and we do cross join, you will get, for example, Canada, Ottawa, Canada, Maple Leaf. Well, that's true, but you're also going to get Canada, Ottawa, UK, Union Jack. That's not what you wanted, but that's what you get from the Cartesian product. Every row here is matched up with every row there. So you're going to have 16 rows, most of which you don't want. To get this, if you do, is select star from table 1, comma, table 2. You can also say select star from table 1, join table 2. They both mean the same thing. To show you this in action, we're just going to switch to MySQL real quick to the terminal. Let me make sure I've set up my tables. So when I go set up source, set up country.sql, from the previous videos, you'll know that that is a command that I've written ahead of time and stored in a file called setup country SQL. So on the left side here, we just have our bash terminal, and I'm just going to show you what that is. So if I cat setup country SQL, you'll see we drop table if exists, table 1. That just means when I run these queries multiple times, if the table already exists, you're going to get an error when you run a create. So these are simple tables. They're the same as the ones we just saw in these slides. You have a country with a capital, a country with a flag. We've inserted some values into it. In this case, there's 5 in each. So we are going to go, so if you go select star from, and I've named them the also convenient table 1 and table 2. You could also go select star from table 1, table 2, and that's your join. So you'll see that we've got the combination, the Cartesian product of all possible rows. Not necessarily what we want. So I'm also going to show you select star from table 1, join table 2, just to show you that it's the exact same thing. It's just two ways of saying the same join. So after saying that that's mostly useless, let's show you one that is actually mostly useful. And this is select columns from T1, table 1, join T2, and we're going to add a command to it on there called on join condition. So we're going to add a condition to our join. And this is called an inner join. This will be the intersection of two tables, and it will give us the information from one table that matches another table on a given column. So here's select star from table 1, they're the same tables as before, join table 2 on table1.country equals table2.country. Now, just as a side note, when you see this here, table 1 and table 2, those are your table names, and they are not strictly necessary. The reason we have included them this time is because on these tables have matching columns. When the columns match, there can be confusion in MySQL, and you have to specify the table. Otherwise, you don't. In the examples later on, you're going to see me do it both ways. Sometimes I'll specify the table, sometimes I won't. And that's why you don't have to specify when the columns when they don't match, when the names are different. What happens when we do this join is we're going to get 4 columns. We're going to get the correct columns because we're matching on country. We get Canada, Ottawa here, matched over here on Canada Maple Leaf. So we get Canada, Ottawa, Canada Maple Leaf. Now you'll notice your final table is going to have country in there twice. And that is because we selected star. We want all of the columns. We could also specify which ones we wanted. We could say we want country from 1 and capital and flag, and we would only have 3. But the default is all 4. Now we will go back and we'll just take a quick look at how that works. So what I did there, that is something that is the \bang, the hash bang, means do a bash command or do an external command, and that's just a clear terminal. That just makes it easier for you to see what's going on. So we'll select star from country, sorry, from table 1, we didn't call them conveniently rememberable names, and you'll notice there's 5 countries in there. And we're going to select all from table 2. And you notice there are also 5 countries in this one. What you'll take particular note of is that the last country is actually different in both tables. So that when we go select star from table 1, join table 2 on table 1.country equals table 2.country, we only get 4. And the reason for that is it's only going to show us matches. It's only going to show us where there is a valid match. What I was saying before with the select, and this should be review, select table 1.country, comma, capital. We don't have to specify the table because there is no collision. Once I learn how to spell capital, and flag. And there we go. Now we've gotten rid of the multiple countries, and that's the table you're looking for. However, what happened to the other 2 countries? Well, what occurred there was we didn't have data for them. If you want to include those, however, because that would be the intersection, we will instead do what's called a left join. And you're going to select columns much the same way as the inner join from table 1. Now instead of join on table 2, you're going to left join table 2 on a join condition. Now what I've included in this one is a where clause. And the where clause you've seen from before when selecting data. Select data from table where some condition exists. You can do a join, and you can do the on condition, and then you can add some where conditions as well to further restrict your selection, to further parse it down. And that's just more of a point of interest. A left join, select star from table 1, left join table 2, will give you this. It will give you to table 1 all of that and the intersection data from table 2. So let's take a look at what I mean by that. So we're going to do the same command as before. Let's get rid of the column selections. So we will select star from table 1, join table 2. I'm just doing multiple lines here to make it a little bit easier to see what I'm doing. On table 1 dot country equals table 2 dot country, and that's the same as before. If we change that join to left, we've now got 5 rows. And those 5 rows are from the left hand, or table 1, column. All rows in the left hand table are going to attempt to join valid rows in the right hand table. If there is no matching condition for the on condition, it will include null. So we'll see that where we have country from the left hand table, the countries from the right hand table, France doesn't exist. Therefore, is inserted a null to show you that there is no match. And that can be handy at times to see the negation, to see when something doesn't exist as opposed to see when something does. Now the last join we're going to look at is actually trivially the same as left join, and it's called right join. And as you may guess, it is going to join from the right hand table as opposed to the left hand table. It is otherwise identical. You will sometimes want to choose one or the other because the SQL queries can get complex, and maybe a right join is a bit easier to follow when reading than a left join. Otherwise, the operation is identical. And what it does is it's the collection of all columns, rows, I was right the first time, from table 2 with all matching rows from table 1. And we will have a quick look at that before moving on. So we're going to do the same command as we did a moment ago, except we're going to right join. So you'll notice that the left-hand table, over which is represented by the first 2 columns, are null because there is no Cuba in table 1. But the right-hand columns are not null. They are the values from table 2. Now, there is something called a full outer join, which is not actually available in MySQL. But there's also a command called union, which is to union the results of 2 different queries. So we will select star from table 1 left join table 2 on the country name union, select star from table 1 right join table 2 on table 1 dot country equals table 2. You can see a certain amount of redundancy going on in here, and how these queries can get quite complex quite quickly. So what we have done there is we have now unioned the 2 tables, and we get both together. We have the 2 nulls. Repeat rows were omitted where they match, and where they don't match or where they're unique to the both queries, we've now got both of them. So the France-Paris, which didn't have a matching in the right-hand table, and the Cuba Lonely Star didn't have a match in the left-hand table. So we have null values. So now we can kind of see both. And that's called a full outer join. And that would be your Venn diagram union, but not the Cartesian product, which will give you a lot more. So now we're going to change pace, as there are no more slides. And I am going to go through a series of examples using MySQL. So hopefully give you an idea to a certain degree of how these joins are used. Now I've got a series, and I'll put these on GitHub later on. Not GitHub, I'll put it on the Sharcnet Git repository. But I've pre-made these commands because it's often easier to do the command in one window and execute it in another. And that way, if you make a mistake, you don't have to worry about the formatting of the MySQL user interface. You can just do it in Vim. So I've got this one already here. It's that's load instructor. I wanted to do create instructor. Then create instructor .sql. And this is what we're going to be building up to. But I'll just do it one at a time here. So show tables. And we can see we've got table 1. We're just going to drop those tables because we don't need those anymore. So now we should be empty, show tables. And we are going to create an instructor table. So we'll use the same commands as before. Create table instructor. We'll give them first name. The instructors have a name. The instructors also have a last name. And they have an email. I generally default to varchar64. Remember that the varchars do combine themselves in the final table, and there's a maximum number of varchar characters you can use per table. For these little tables, we're not even going to come close. Okay, so I didn't actually put an error in there. Oftentimes you will mistype those, and you will get an error. If you attempt to create the table again, you're going to get an error that already exists, which is why if you notice here on the left-hand terminal, I do drop table if exists instructor, because also if you drop table a table and it doesn't exist, you'll also get an error. So adding the if exists, drop table if exists a table, still give me an error. Don't worry about it. So we have created the table, and we are going to describe the table, which is how you see what you have done to make the table. Interestingly, I created the table and completely forgot the ID, which is convenient because we can alter table. So we will do alter table. Alter table, we've got to put the table name down, which is instructor. We are going to add a column, ID, integer, the same as you would before, enter, describe table. Nope, not describe table, describe instructor. There we go. And now you'll see that there is an integer row where there wasn't before. However, if you want that integer row to be in a specific spot, you can tell it where to go, because oftentimes you want the ID at the beginning, just so it's convenient for you to look at. So we can also alter table instructor to drop column ID. Describe it again, it's gone. What we'll do is we're going to go back to here, add column integer, ID integer. Now you can tell it where to go. First, describe table. You can also, if you like, modify column ID integer first, and you can tell it to go after something. We'll go after last name. What did I do wrong there? Alter table instructor, modify column ID. Oftentimes, it can be difficult to see where you've gone wrong, which is why it's best modify column ID integer after last name. Take my word for it. Moving on. We are going to start inserting. Oh, what's that table look like at this point? Now I've forgotten where I'm at. Describe instructor. And what that will let me do is just paste that down there. There we go. So somewhere in there, I had mistyped something. Staring at it for a while is not going to get us anywhere. So now we'll describe table again. And now it's where I want it to be. It's after first name. We're going to drop this table. We're going to source the document I have over there on the left so that I get the table that I want. Actually, I don't want the primary key. We're going to get rid of this stuff for a moment. So we'll get rid of the primary key. We'll get rid of the auto increment. Make sure we write it. Source create instructor.sql. Describe instructor. And there we have the table that we want, minus the primary keys. I understand that sometimes this can be a bit redundant and a little annoying to follow, but this is, again, this is like the root of some of the things that you're going to be doing with it. You'll see this everywhere, really. So we just kind of trudge on. There was a command that I went through earlier called show create table. And as we had describe table, which is telling you what's going on in the table, in a nice user-friendly sort of readable way, show create table instructor doesn't. It's not quite as pretty. And makes a bit more sense if I go full screen there. However, what it does is it gives you the create table instructor command, and it shows you some of the stuff that is done by default, which is they've set the default null in there, which is to say that the default value is going to be null. When you create the table, you can change that to be whatever you want. And then some other stuff, character sets, the engine, so on and so forth. So the difference between describe and show create is one is a bit more readable for the user, the other one's a bit more readable for MySQL. However, the reason I show you that is that sometimes you need to drop constraints based on their name, and the name may have been created automatically, or you may not remember what the constraint name was, and you'll use the show create as opposed to describe to get the name of the constraint in order to remove it or alter it. So if we insert something into this table, we will insert into, insert into instructor values. We'll give it the ID, a name, a last name, the pinnacle of creativity, and steve@email.com. Do a success. We'd like to see that. Query OK. Select star from instructor. There we go. We got ID, first name, last name, like we just said. Now, what if we want to do it again and we want to change the name? Well, Billy's at bill.email.com. It's OK. And the reason that's OK is because we didn't put any constraints on ID. What we want to do is we want to use ID as a primary key, so we're going to put the primary key restraint on it. And as you'll see over here on the left-hand side, we'll just alter the SQL file, and we'll call it primary key. And right. Source create instructor .sql. Here we'll describe the table. You'll see that we now have a primary key there. We'll show create table if you like. Show create instructor, create table instructor. And you'll notice that ID is now not null. And the reason for that is primary keys down here done as a table constraint, while I put it in as a row constraint, as a column constraint, it automatically translates into a table constraint when they create the table. And it adds a not null because all primary keys must be not null. Just being clear. We will now insert the two guys again with the same ID and see what happens. So there's Steve Stevenson again. Yep, everything's all right. And how about Bill Billies? Bill Billies now throws an error, and the error is duplicate entry 0 for key primary. So it's a primary key conflict. And that means that we had to change this to something that does not a, rather 1, that does not exist in the table. And of course, that becomes redundant after a while, which is now why we add auto increment to the primary key. Because there's no reason for you to have to go look it up to say select star and max the ID and then do it by hand. The table should and does do it automatically. So we will, I am just arrowing up here, the same as bash. We got two queries there because of the drop table and the create table, and we'll insert those values again. So insert value. This time we're going to insert Bill Billies. Now note, because we are omitting the ID column, we actually have to tell it what column names are we are entering into it. So we're entering first name, last name, and email values. Select star from instructor, and you'll see that he's got an ID of 1. We will add some again, and we're actually going to omit the email just so you can see what happens. And we're going to use old Steve Stevens again. My creativity with names knows no bounds. At steve.email.com. Oh, we're going to omit email. We'll go back here. We'll omit email because we've only put in first name and last name for the columns over here. Hit enter. It's okay. Select star from instructor. It has put in null. And that is because when you create the table, the default is null. So now what do we do? So we've got this table. What can we do with it? Well, before we move on, I'm actually going to show you one more thing for auto increment. Setting auto increment, what time is it? There. You can change your auto increment value at any time. So sometimes you might want to start your values at 1,000 or 10 or whatever. So that command would be, it's an alter table command again, instructor, auto increment. So it's a variable on the table that you didn't set but is there, 1,000. Add another record. We're just going to add Steve Stevens again. It is twin. And you'll notice that the ID is not at 1,000. That's because we changed the last or the next auto increment value. However, I would like to just insert a bunch of data into here. So what I'm going to do is I'm going to use this command. So cat load instructor.sql, and it's going to delete values from instructor, alter the table, set auto increment to 1 because I want to restart. Even though you've deleted the values from the table, the auto increment is going to be wherever it left off. So if you added 15, the next will always be 16. Regardless of what's in there, it has to do with the current auto increment value. So source load instructor.sql, and that's just loading the CSV values there. So if I select star from instructor, you'll notice I have those. So in the same way, now this time I'm not going to go through all of the details of the different bits, but I'm just going to create a table called class. So cat create class.sql. The difference between the previous table and this one is I am referencing instructor ID. So I'm referencing the external table of instructor, which was already created, on instructor ID, which matches as an integer. So this is a foreign key column. This is the foreign key constraint. We'll have integer, primary key, and auto increment, a department code, a course code, and an instructor ID. Because this would be the idea of you've got these instructors. Now what courses are they instructing? And this is the one-to-many relationship. Every instructor can have many courses. Every course only has one instructor. Whether that truly represents the world is neither here nor there, as this is an example. So, source load class SQL. Oh, did I not create it? Oh, let's create the class. And no space. That's how you know it's live. So the next file we're going to do is load class.sql, which is going to load this comma separated value file called class. Source load class.sql, and now we have values in class. We'll just show you select star from class for what we have, and those are the values that we put in there. And I have noticed, or you will notice, that I've deliberately put in a couple of null values in there, and that would imply that there was no instructor assigned to that class. So at times you might want to look that up. Now there's an interesting thing, or a caveat. You might not find it interesting. When loading values using the load data local command, load data local, you can't load null values. You can load blanks, but you can't load nulls. So if I look at the class.csv file, there are some -1s in there. Well, there is no such thing as a null number in MySQL, but I can say -1 set instructor ID, so that is the column or the row, column that I defined up here, to null if, so set it to null if this is true. Instructor ID is -1. And that's a way of getting null values from a comma separated value file. Just a handy thing to know. Oh, not class, clear. So now that we have this class file and we have this instructor file, what's the point of it? Well, the point, of course, is going to be we're going to do merges on it. We're going to put them together. We're going to make selections and see what data is there, and that's kind of the whole point. The point is not to put it all into one table, but to put it into multiple tables and see what we get. So of course, if you select star from instructor, join class, we don't want that. That is your Cartesian product, and that is all the possible things. If you've got large tables, that may freeze up your terminal, and you're just going to have to terminate the session, because you could get millions upon millions of results that you're printing to the screen. So what do we want? Well, we want to do a select join class on instructor.id equals class.instructor_ID. And there we go. Now we can take a look at everything, and we can see what instructors are doing what courses. Now, if you return this either as raw data or as, sorry, this blue border is cutting things off in such a weird way. Anyway, so if you want to return this to make this data make sense, well, this doesn't not necessarily what you want. You've got ID in there twice. You've got departments and course codes separate. You've got instructor IDs and IDs. There's just too much going on there, most of which you don't want. And that is why we are going to do some renaming and some moving around of data. And this is just using everything we've already done, and just to show you how it kind of applies. So we've got this select star from that. So say we don't want, we don't care about the ID, we joined it. So we're going to go first name last name. You'll note that I didn't put in the table name because those are unique. Email, department code, course code. And there we go. We've selected certain columns. Maybe we want to put first and last name together, because you don't necessarily want to, maybe you want to return it as if it was one. And this is something I haven't actually introduced before, is a concatenate command. And it's the same as pretty much concatenate in any number of languages, in that it takes multiple strings and sticks them together. And there is a whole list of these string functions that you can use. Look them up on your own time. A very and easy to understand one is concatenate, stick strings together. We are going to stick first name, last name, and space together. And there we go. Now we have a column where their names are contiguous. However, it's kind of an ugly column name because it defaults to column name through the string command you just gave it. So we are going to stick in an as in here. So what happens is, if you want to rename a column as name, there. Now we've set the name to it in the selection. It hasn't manipulated the original tables, only the resulting query. You can also do this with things that weren't used for string functions. So say you want email, you can go email as email address, and then it'll rename that column. This is also another way of getting around column conflicts or column name conflicts when you have multiple tables. Now, as an aside, you can also rename your tables in queries. So we've got first name, last name, email. Say we wanted ID as well. We're going to put ID in there. We're going to get an error because ID is ambiguous. So we would put in instructor.id, if we could spell instructor. And now it's going to put that in. However, in some of your longer queries, your table names, which could be much longer than just instructor, might be a bit tedious. So over here, or maybe it'd be easier if I clear the screen a bit, and we look at that, we can actually rename the tables that we're using in the query. So we'll call instructor T1, and that means over here, instead of saying instructor.id, I can say T1.id. Except, put that S back in there. We got an error there, unknown column instructor.id. Over here, because it no longer exists, it is now T1.id on class. So you can oftentimes do class T2, particularly if you've got a lot of multiple joins going on. You can rename your tables just to make your commands or your SQL queries a bit easier to follow. And that's just to show you that you can some of the renamings you can do. Not to say too much. Let's move on. So we've concatenated, we've done column aliases, and we've done unions. So just to soak up the last couple of minutes here, there was something I wanted to cover on a many-to-many relationship. So just to quickly go through this, I've already got the commands made for expediency, and we are going to create student.sql. So now we've got another table called student. Describe student. What's student got? Student's got the ID, first name, last name, email, the same as an instructor, but it's a different table. We are going to create enrollment. What is enrollment? Well, it's your join table, right? Sorry, source. Right, enrollment.sql. There we go. And sometimes my fingers are just not cooperating. Oh, it's source. Ha, there it is. source, creating from a source. So we will describe enrollment. There we go. And it's only got two things. It's got a class ID and a student email. And what we're going to show you here is that you don't have to do joins on primary keys. Up here, you'll take note that the email is unique. Therefore, it's a good column to do a join on. It doesn't even have to be unique to do a join, but we're just doing it in this case. You'll also note that there is no keys. There are no keys in the enrollment table, and that is because this is the table to represent the many-to-many relationship. Class ID is a key in a different table. Student email is a unique column in a different table. And this is just so that you know how to put them together. And this will represent the relationship between the two. And it's kind of a helper table, as we described in the slides earlier. So we will load some data into here. It would be amazing if I could type something correctly the first time. Student.sql, SQL, source load. Moment.sql /bang clear. Select star from student. Select star from enrollment. And there we go. So we got these two tables. One is a class ID and student email, and the other one are your students by name, email, and ID. Now what we're going to do is we're going to do a bit of a query on this. And in order to do this query, we are going to do a temporary table. So what is a temporary table? It is the same as a regular table, except that when you log out or when you end the session, the table disappears. So create temporary table class list. That's going to be the name of the table. It is going to be created from the result of this select command. So you could select the same as you normally do. Select all columns from student table, join on enrollment table on email. And there we go. And those are all of your students and what class they're in. If instead we do create temporary table class list, let me spell the class list correctly. Show tables. Drop table. So and the show tables didn't show up because it's a temporary table. But we're just going to drop table class lsit and fix my spelling. Create temporary table class list. Select star from class list. And you'll note it's exactly the same as our select. So now we have a temporary table that will be done at the end of the session. So if we update the other tables and you start a new session, do that again, this table will be updated because it'll be created anew. And that's what it's handy for us, to make it easier to kind of piece together these queries. So now that we've got this temporary table, we're going to do a couple of manipulations on it. We're going to alter table class list, add column class name, varchar 64. Select star from class list. We now have another column in there called class name. We are going to, if you were to select from class list, join, and now, as an aside, so select star from class list, join, select ID, department code from class. So we've selected from class and joined it to class list. By putting the parentheses around this, we have created a table within the query. So this is not really a temporary table so much as it is an alias for a table. So we've selected that, created a table, and called it T1. It's been then joined to class list on T1.id equals class ID. Now this takes a bit of time to digest, and I'm just going to leave that sitting there for you to think about later. But what's important here is to realize that this is the same as having a table. You just do it temporarily for the duration of this query. What are we going to do with that? Well, nothing right now, but we are going to do an update. We're going to add update to it. Update means change values that already exist, and we're going to update class list. Class list is going to be updated using the result of this join on the same as before, except that we are going to add a thing at the end here, or a command at the end here, set class name, which you'll realize is the null values in this column. Set class names equals concat, and that is our string command from before, department code, which you'll remember, or you'll note, does exist in our join, comma, we'll give it a dash this time, comma, course code. And what we are going to do is we are going to copy and paste the one I did earlier to get rid of my typing mistakes. There we go. Voila. As if I typed it. Select star from class list. And what have we got? You'll notice that class name is no longer null, but because of the update command, it now contains the values concatenated from another table of department and class number. That one is kind of what we're building up to. We're going to end there because that takes some time to digest, and we are 6 minutes over time already. So thank you, and I will invite any questions from the audience now.